And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here on the G3. Can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere. The light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has two predominant lines. One is a really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are, about 30 minutes away from totality. But you can explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, the lack of radiation, this perfect cloud that the moon makes affects the Earth and its turbulence. And, I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.
Wow.
And that's great.
Amazing, yeah.
Thank you to those of you on the G3 to fill us in on what you're going to be seeing from there. Here we are on the other side of the country, here at Charleston, South Carolina. I want to give a shout out to the college. The students here have been so incredibly great for us, and we are actually going to have a chance to go back to Salem, Oregon, and find out a little bit more about what they are seeing there. They're talking about this moon picture right here.
Right, we've got a live picture right now from Salem, Oregon. We were showing you earlier in the broadcast, and as you can see, as we've been sort of describing it as the moon taking a bite out of the sun, it's continuing to happen, and what it looks like, Karen, is like it's almost like the sun. What we see is almost like a crescent moon, but it's not. It's the moon is actually the black portion in the upper right-hand portion of the sun that's being blocked out as we get closer and closer toward totality, which, as Robert and Thomas said from the G3 aircraft, is only about 30 minutes away for folks in Oregon.
And we will go right to Madras, which is right near Oregon. This is another view of the eclipse. One of the great things about this particular eclipse, Sean, right, is that the totality will be over land for so long. So we're about to start seeing it in Oregon, but normally, you know, most times when you have an eclipse, a lot of it happens over the ocean, right? The ocean gets to see it.
Right. So for folks, especially here in the United States, this is the first time from coast to coast that we've seen a total solar eclipse since 1979. And so that's why for a lot of folks, we're talking about this being a once-in-a-lifetime opportunity. And remember, it takes about 90 minutes for the totality portion of the eclipse to cross the United States, the continental United States. So as they mentioned earlier from the G3,
outer layers of the sun. There's the photosphere, that's the part we're seeing now. There's the chromosphere and the corona above that. The chromosphere and the corona, that's the solar atmosphere. Now what's cool about today is that usually we get to see the photosphere, the visible surface of the sun. But today, during totality, we're going to get to see the atmosphere, the chromosphere and the corona of the sun. And we don't usually get to see those because they're so much less bright than the sun. It takes something special like today's total solar eclipse to be able to see them. So that's really amazing. We're going to get to see that.
It is so cool. So I think what we're going to be doing now is sending it back to NASA's Eclipse Central in Charleston. Take it away, guys.
Thanks.
And welcome back to Charleston. You can hear these students are really excited for us. And I got to tell you, I had the chance to interview some of them just a few days ago. The College of Charleston students are excited, and I wanted to find out what they knew about the eclipse. Let's watch the video.
all right. So right now what we're looking at on your screen is
Hello, I am Karen Fox with NASA TV. I'm here at the College of Charleston in Charleston, South Carolina, and we are going to spend some time interviewing students to find out what they know about the total eclipse of 2017. What's happening on Monday?
The solar eclipse is happening.
Monday, the eclipse.
That's the right answer, the eclipse. Are you ready for the eclipse?
Oh, I'm pumped. I've been talking about it all summer.
What is an eclipse?
When the moon moves in front of the sun.
It's when the moon passes in front of the sun and creates a shadow on Earth.
What is the closest star to Earth?
The sun? The sun.
The sun.
The sun? Yes, the sun. Very nice. Will you demonstrate for me putting these on?
We're going to put them over the glasses.
The music you associate with the eclipse. What have you been listening to? What are you going to listen to?
Here comes the sun.
Total eclipse of my heart.
Do 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 do.
Da-na-na, like, I saved every letter you wrote me.
So I was really impressed with how much these students knew. We had a great time here. And now you can once again see the imagery we are pulling in of a white light telescope of two eclipses happening as we speak. These are again the partial eclipses, Salem, Oregon, and Madras, Oregon.
right. As you can see, it's quite an image as that moon continues to progress. Transit is the term over the surface of the sun, getting closer and closer toward totality. And again, asking about that, you must have the glasses unless you are in the path of totality and during those brief moments of totality.
Right, and Sean is stressing the glasses, but of course you can also watch the sun indirectly. There are a lot of ways. Nikki Weil, a solar scientist, just told us that you could even pull out a colander because it's got little pinholes in it. You can use a Ritz cracker that has a hole in it. The other thing is you might even see the eclipse image filtering through the space between leaves on our tree. There's some really wonderful ways of catching imagery of it. So, you know, be safe, but don't think you absolutely have to have the glasses. That is not your only option. Should we talk a little bit about the science that NASA's
we should, but
doing
before we do that, I just want to give a shout out too to our website because you're talking about all these great ways to indirectly view it. And again, just a plug for the eclipse2017.nasa.gov site where you can find all kinds of information, but especially some do-it-yourself instructions on how to create some of those indirect viewing methods.
Great, we've talked a lot here about the partial eclipse. Nikki Weil, who you just heard talking, she studies the corona, that is the atmosphere around the sun. And she was telling me just the other day how excited she is that she is going to be able to see that with her naked eye during the actual total solar eclipse. So that's what's interesting. We can only see that normally from space with our space telescopes.
Right, and even with that, I was talking to one of the heliophysicists back at NASA headquarters in Washington, D.C. Recently about this, that even with those artificial eclipses that they create from the coronagraphs, they're called, in space, it doesn't give you the same viewing opportunities that we have with a natural eclipse like we're seeing now. That there's actually a couple different layers of the sun's corona. We have the outer corona and the inner corona, and because of the way those coronagraphs work, they do not allow a good image of the inner corona, the part that's really close to the sun's surface. Only the outer corona. It's only during an actual natural total solar eclipse like we're viewing today across the country that scientists, heliophysicists, and others, and just the general public are able to see the entire corona, and that really gives them a lot more information. And remember, for these scientists, no matter where they are, they only have that brief, maybe 2 minutes, maybe 3 if you're really lucky, right in the center line of totality, to see the entire corona and get those measurements.
Yeah.
Sounds like you do a lot of outreach as well, and it thrills my heart, and I'm sure it thrills your heart to see so many of these young people. You probably did not have to drag these young people kicking and screaming to do this help, did you?
No, we brought 4 institutions with us, and LSU is the home team, and so they were always coming, but we actually had a competition to figure out which other students we would bring, and we brought a team of 46 people.
Okay, and right behind you now, I had forgotten they're launching 2 balloons. Now, the first balloon, I think we have a video of the first balloon. Okay, we're getting ready to launch the second balloon.
Both of our balloons launched already. That's
okay.
The balloon,
the first balloon, Colleen, that was launched, where is it right now? Maybe 2,000 feet, you think?
They go up about 1,000 feet a minute, so a few thousand's probably been a couple of minutes now.
Okay.
So.
There it goes. This other one has launched. It's a big yellow balloon filled with helium, and the next time we see this balloon, will be down on the ground. It'll have wonderful data. Can you tell us about what goes into studying the winds and the weather reports, trying to calculate where this will land so you can quickly retrieve it and get your data? That's a whole nother science.
Yeah, so I'm not an expert on it. I can just tell you that we do our predicts. We started our predicts months ago, doing them, maybe every week or so, and then the last few weeks we've been doing predicts every single day. So we have a good idea. We think it'll go about 36 kilometers, about 22 miles due east, somewhere near Marion. So we'll have several chase vehicles kind of staged and ready to go. And I'm not sure if they decided to leave before or after totality, but we have some local people helping us to make sure we have access. And we're hoping, expecting to be a pretty easy recovery.
Now, will you actually be on the chase team yourself?
No, I'm not going to be on the chase team. I need to do logistics here on the ground. I have been on a chase, though, and it's very exciting.
Oh, I'm sure. Yeah, can you tell me about it? And please get as specific as you can. What are some of the most eventful ones? Like, has the balloon ever come down in
Pontchartrain River?
How did you know? You're not kidding me.
I'm not kidding you. We did have a landing in the Pontchartrain River, which was not a great recovery, but it was definitely better than landing in the airport, which we were afraid was going to happen.
Well, I was going to say I would rather land in an airport, because the Pontchartrain River, you have the water that might damage some of your instruments, but you're the expert then, right?
I think we'd rather not interfere with air traffic control.
That's true. Landing in a Pontchartrain River, and I assume the alligators did not make a meal out of your several $1,000s worth of instruments?
We didn't recover that payload, but we have done water recoveries in the past, and we actually just invested in an inflatable kayak.
Okay. My producer just told me we are seeing first contact. Everybody, we have people putting on their glasses the first contact. We are seeing the first contact, and we've got about 4 minutes left. How many total solar eclipses have you seen, Colleen?
This is my first.
I assume you have your glasses. Feel free to go ahead and put your glasses on.
You want a pair?
Yes, please.
Your fingers together. You can make little spaces in between your fingers.
If you don't mind, I'm gonna.
You can project little images of the eclipses down onto the ground. So make sure you look down just as much as you look up.
Really see through them.
Right. Okay. My glasses are on. Are your glasses on too? Okay. And this. the sun. We are turning around. Would it be okay if I turn my back to the camera so I can see the sun? Oh, okay. I'm going to turn my back to the camera. Oh my gosh! There is a small bite starting in the sun. What are your comments?
I said that is gorgeous, isn't it?
That is fantastic. The total solar eclipse in Carbondale, Illinois has begun. A small bite is being taken out of the sun by our satellite called the moon. This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes if I want to, take a break on my computer, I can take these out. I will go to the solar, I think it's the Dynamic Observatory that often will give videos of the rotating sun. And Colleen, I don't know about you, but when I see that giant ball of gas just rotating, majestic is a word that comes to my mind. Could you agree?
I absolutely agree. It's amazing, and I think that we're really fortunate to have this opportunity and to be in community with our students and faculty and staff from multiple institutions here at SIU, who's been wonderful and very welcoming. It's just extraordinary.
It sure is. Thank you very much for your time. Keep up the great work. Thank you for talking with us. That was Colleen Fava with the LSU.
Thank you so much to
thank you,
Carbondale.
Carbondale. Oh, that was amazing.
It's great, and I love looking at those images and how you can see different things at different parts of the country. It's wonderful to be sharing this imagery with all of you. We will have more from Carbondale later today. Please stick with us. We have so much coming up.
From there and from here at NASA's Eclipse Central here at the College of Charleston.
Looking out toward the horizon, we await the first glimpse of a total solar eclipse, when the movement of our moon completely blocks our view of the sun. Starting in the air from NASA's Gulfstream 3 aircraft off the coast of Oregon, we anticipate this awe-inspiring celestial event. Over the next 3 hours, we will track the solar eclipse as it moves across the entire United States from coast to coast, observing this incredible event through the eyes of NASA. Hello and welcome. I'm Dwayne Brown from NASA's Office of Communications, and over the next 3 hours, we're going to look through the eyes of NASA and experience today's total solar eclipse. I have a great team here on stage. Joining me to my immediate left is Jadi Collado Vega, who is a space weather scientist. Solar scientist next to her, Alex Young. Over to my right, John Yimbrick, who will be taking your social media questions today, plus media specialist and meteorologist. Just very important man today, I must say. Tracking the weather conditions across the path of totality, Sean Potter. Today we're coming to you from NASA Eclipse Central here at the College of Charleston. Now, Charleston is the last stop of the total solar eclipse on U.S. soil. So we will track this eclipse as it moves east and heads this way. We're tracking the eclipse across the entire country to bring you the best images with the most compelling stories, along with science experts. Here from NASA Eclipse Central, we have views from ground telescopes, high-altitude balloons, airplanes, and from several NASA spacecraft. And yes, and I want you to remember this, audience out there, we even have live, no one else, only here at NASA, the International Space Station. If you want to see the eclipse as never before, stay with us through the eyes of NASA on NASA television. This is the place to be. Jadi. Hola, ¿cómo estás?
Bien, ¿y usted?
Okay, this is a win-win situation for America. We have a partial eclipse and a total eclipse. Explain the difference.
So today, pretty much, the moon is going to come across the Earth and the sun. So North America, Central America, and parts of South America are going to see a partial solar eclipse, which means that the moon is going to partially block the sun. It's going to look like the moon took a bite of the sun, like you have seen on the previous images. A total solar eclipse is going to happen in a very narrow path, 70-mile wide, that comes all the way from Oregon, crossing the whole continent of the United States, and getting out here in South Carolina. You're going to see a total solar eclipse, which means that the moon is going to completely block the surface of the sun, and you're going to be able to see the solar atmosphere, the solar corona, with your own eyes. Day will turn into night, which means the stars and the brightest planets are going to come out.
Jadi, Alex, you guys have been waiting for this for a long time, as all these other scientists around the nation. This is the day we've been waiting for, and we're here, Eclipse Central. You guys, if you're here, this is the place to be. We have remote NASA TV broadcast sites along the path of totality so that anyone watching along with us can also experience the total solar eclipse. We'll also share information about how to experience the eclipse safely. Wherever you are, and give you a peek at all the exciting plans NASA experts have today. Alex, okay, so Mr. Solar Man, what is so unique about the solar eclipse?
Well, this is an amazing opportunity. The last time we had a total solar eclipse in the continental U.S. was '79, but the last time we had one that went from coast to coast was 1918. 99 years ago. So we are having a total solar eclipse that's covering a huge portion of populated, accessible land. This is giving us an unprecedented opportunity to study, to look at the impacts on the Earth, to see the corona, and give us science like we've never had before. I mean, the last time we had this kind of connection to where we are and who we are was actually really the Apollo 8 Earthrise. And that gave us a perspective outside of just the Earth. It showed us that we were part of something bigger. And that's what this total solar eclipse brings for us. It allows us a window into the universe. And this is the most connected, most well-observed event that we've ever had in terms of a total solar eclipse. The data and the experiences are going to be amazing.
Okay, so we're certainly witnessing a monumental celestial and historical event today. We'd like to take a moment to talk about safety. So, Jody, can you help me out here? So,
I will help you out.
You never look directly at the sun, and you may have seen these eclipse glasses, and they're designed with special purpose solar filters. Ordinary sunglasses, even very dark ones, are not safe for looking at the sun. Now, if you're in the path of totality, there's a short time frame that you can take your glasses off. This is only when the moon completely blocks the sun, and that is during totality. Let's watch this video to learn more. Okay, so Alex and Jody, I'm very fortunate that I have glasses, and a lot of people have glasses, but a lot of people don't have glasses. Yes. So what are other options? Let me start with you, Alex, on how they can view the eclipse.
Well,
safely.
The simplest thing to remember to look at it indirectly is a pin pinhole viewer. And there's a lot of ways you can make a pinhole. You can take a simple piece of paper, poke a hole in it. In fact, I've got here a 3D map of the path across the U.S. with a hole in it that I can use as a pinhole to project the circular sun down on the ground, and then you can see the moon move across it. As a matter of fact, anything with holes, including this colander, is something you can use to look at the eclipse. But you can also use something a little more sophisticated if you want.
So you can actually make a box. You actually just do 2 holes in one side of the box and then put white paper on the inside. Then put aluminum foil, do a hole in the middle, not too big, that you can actually project the sun inside the box. Make sure that the sun is actually behind you so you can actually look at it inside of the box. It will be an amazing projector.
Okay, so before I toss the social, I got to do this because we're on the College of Charleston, and College of Charleston students, make some noise! That's what I'm talking about. Okay, so the social media world is going to break records. So let me toss to my man, John, on the social front. What's going on?
Thanks, Dwayne. There are literally millions of people watching this broadcast right now. We're going to be monitoring the conversation online and taking your questions as a total solar eclipse treks across the United States. There's a tremendous amount of excitement online, and we should want to share with you at home. So we will show you images of the eclipse from your unique vantage point. Submit your pictures and questions using the hashtag Eclipse 2017 and follow the conversation online. For updates, be sure to follow, let's see if I can remember all these, NASA on Facebook, Twitter, Tumblr, Instagram, Snapchat, and LinkedIn. Additionally, we're providing live coverage during the eclipse on Facebook Live on NASA's Facebook page. You can ask your questions in the comment thread. Check out their streaming sites like NASA's Periscope account on Twitter, Twitch TV, Ustream, and on YouTube. And of course, you can watch it on nasa.gov and nasa.gov/Eclipse Live and on the NASA app. And we have a special feature for you. If you visit our Facebook Live page, along with this broadcast, we have a 360 view from right here in Charleston, South Carolina. With this tool, you can pan around on your computer and mobile device and even look up to the sky as the moon transits the sun during the eclipse. It'll be like you're right here with us in Charleston, minus the sweltering heat. Visit the NASA Facebook page and check it out. And finally, share your images of the eclipse with us using the hashtag Eclipse 2017 on our Flickr page, which is up here online right now. Share your images with us, and we'll share them right here in the broadcast and also on social media. And finally, enjoy your eclipse viewing, and remember to ask your questions with the hashtag Eclipse 2017. Back to you, Dwayne.
Well, John, it's social media is going to break some records, and we're going to be coming back to you more and more. So you got to know that one of the most important things here for today is the weather. So Sean, you know, I'm looking at Charleston skies. We got clouds. I hope that's going to get better, but what's going on around the nation? Over to you.
That's right, Dwayne. Yes, the weather is the key factor for viewing today's total solar eclipse. Right here in Charleston, it's about 86 degrees, but with the humidity, it feels more like 99 right now. But what we want to do right now is show you a satellite image from our friends at NOAA, the National Oceanic and Atmospheric Administration. This is from the GOES-16 satellite. It's a brand new weather satellite that NASA built for NOAA and was launched last year. That's going to give you the latest and greatest, very detailed imagery of cloud cover across the country. And what you can see is that things are looking really good for the early parts of the path of totality. totality, places like Oregon and Idaho and Wyoming, and then as you get into parts of the middle section of the country, more places like Beatrice, Nebraska, maybe into Kansas City, Jefferson City. There is some cloud cover there that may hinder your ability to view the eclipse. And looks like as you get into Carbondale, skies are still pretty good there. There are some storm systems developing to the north in other parts of Illinois. And really, things are looking clear again until you get back here in Charleston. As you said, Dwayne, I'm looking up at the clouds to where the sun will be in about an hour. And there is significant cloud cover, but we're keeping our fingers crossed. I do see some pockets of blue in there, so hopefully we'll get to see something, but we'll have more for you later in the broadcast. Dwayne?
Thanks, Sean. Hopefully you can use some of your connections to get us some good weather here in Charleston. So the moon is already moving across the face of the sun. We're getting close to viewing our first total eclipse of the day. We're minutes away, and remember, the total solar eclipse starts on the west coast of the United States in Oregon, and we will be bringing you live images as it occurs. NASA's Ames Research Center's Jesse Carpenter is standing by in Salem, Oregon at the Oregon State Fairgrounds. Jesse, give us a status report.
Oh, wow. Thanks, Dwayne. Totality is almost here. Oh, this is so exciting. And just before we get to that, though, I want to introduce Andrea Edgecombe again from the Oregon Museum of Science and Industry. Hey.
Hi.
So tell us just quickly, tell us a little bit about this really fun, cool viewing event that's going on here.
Yeah, well, we are here. We have almost 9,000 people here at the Oregon State Fairgrounds, and we've had some cool stage presentations. We heard from NASA astronaut Don Pettit. He's an Oregonian. We had a University of Oregon professor, and behind us we have some space science partners who've been doing some cool educational activities and really interacting with the crowd. So it's been an awesome morning, and we can't wait for totality in a few minutes.
This is such a great event. Thank you for joining us again. We really appreciate it. Yeah, I know you got to get going.
Yeah,
so
thank you.
It's coming soon. And joining us now to talk to us about the sun and give us more information is NASA lead scientist for Eclipse 2017, Madhulika Guhatakurta from Ames Research Center. Hi, Lika.
Hey, Jesse.
Hey, it's almost here. It's almost here. So, how many eclipses have you seen?
I went to see 9 eclipses, and I actually landed up seeing 6. The other 3 had inclement weather.
Oh.
We don't have that here today.
No, we don't, and it's going to be 7. So, what can you tell us about the sun that'll help our audience understand better?
I just want to start by saying I'm in awe at this moment right now, and whatever I say, kind of take it with that filter, because we are very close to totality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfing, generating this environment called space weather. The inner edge of the corona that you see that's black in the video is because the sun is so intense that it overwhelms the dim brightness of the corona. And so even from space, we can't absorb the inner part of the corona. And not only Earth, but the entire solar system, as you can see, lives with this dynamic star. corona is the region where space weather is born and conditions are set for a supersonic solar wind and a super hot corona, two of our outstanding questions in heliophysics, in physics, really. To understand the corona better, NASA is actually going to be launching a mission next year, almost a year from now. How coincidental, called Parker Solar Probe. It is actually going to go touch the sun, you know, and it's going to get closer to any other spacecraft has gone before to the sun to study the corona, to actually sample the very corona that we will be seeing very soon.
Yes, we will. It's almost here. Thank you. Thank you, Lika, for joining us, and thank you for sharing that. So now we're going to take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, now, just now coming in, we have an exclusive sneak peek of the total solar eclipse, and it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view. And now we're looking at the first glimpse of the total eclipse from the ground. Now, wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon. Where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
That's so pretty.
That's the G3 there. Is that the real thing? Is that the real?
the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Jody. What we got? That looks pretty cool.
I mean, it's breathtaking. Even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance. You know, Sean, and get that weather up here looking good here in Charleston. Now, what do we...
So, Alex...
Alex, what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem. Yeah. Okay, so you're seeing the bright... Actually, the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah. So Alex, now, a reminder, Alex, so when that diamond ring pops up, that's what people should put
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on. Yeah. So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I mean, being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. Right. That is the origin. That is where the origin of space weather.
Yes.
That's where it comes from.
That's where most of the solar flares and the corona mass ejections, big explosions of particles, originate from.
Now, if there was solar activity, would we see it right now? Would we be able to see that popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's a diamond.
That's the diamond ring again. That's amazing. That's from Madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So, Alex, explain that and safety too, right?
So, right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like juice. They got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably
gasping.
Completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent which is the sun basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so, Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from. Well, when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're going to see something like this today, and you saw it. But you're going to see it better because nature does it better than we can actually do it artificially. Right now, the activity is not, there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you're seeing on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls? There in Idaho Falls?
I am absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird we have a crescent sun instead of a crescent moon. This is the I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago. And things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho, and they right now have an exhibit on space, but we also sent in a team of experts. And for the past 3 days, we've had talks. We've had demonstrations. We've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them solar system ambassadors. They are all along the path of totality, and they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Stemper. Hey, Richard. He has been manning in this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a place, a school in Southern California. Take a look. We apologize, there is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up, Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a solar system ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime. Wow. But is that as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground. One will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right, I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation?
I have to do this too.
All right. And watch, and we can talk. All right,
Oh,
so
what
we
a
still...
little sliver.
Just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth's sun line is tilted by 5 degrees, and so there's only 2 places where the moon and the Earth
great. We have another one. I think we have time for another with Tina from Facebook's asked, if I place a lens from the Eclipse viewing glasses over a viewfinder on my iPad, could I successfully video the eclipse, or would it fry my camera?
Yeah, you can actually look with the iPad or your phone to the eclipse. The only thing is, you have to be very careful not to look at it with your own eyes without the actual safety glasses. Never look at it through any lens.
Okay. This is Mickey from Facebook. Hey, NASA, International Space Station, see the shadow of the moon crossing America from space. Do they have that view when they're looking from space?
They do. And that's what we're hoping to see from them. Yes.
Excellent. So, John, we're going to come back to you. So I think we're going to go back to Sean, our meteorologist. Let's learn more about how NASA is studying the Earth and Sun relationship during this eclipse. Sean, can you tell us more about that?
Right. Thanks, Dwayne. So during the eclipse, the moon acts like a giant cloud as it passes over areas in the path of totality, casting a large shadow on Earth's surface. Now, the footage you're seeing right now shows a solar eclipse that occurred in March of 2016 over Indonesia. That experience helped us determine how best to study today's eclipse. These images were taken by NASA's EPIC instrument aboard NOAA's Deep Space Climate Observatory, or DISCOVER. It's just one of the instruments we'll be using today to study the eclipse as we monitor changes in Earth's energy balance. Scientists have made extensive atmospheric measurements during eclipses before, but this is the first opportunity to collect coordinated data from both the ground and from a spacecraft that observes the entire sunlit Earth during an eclipse. Dwayne, back to you.
Thank you, Sean. Okay, so now we have a special guest with us today, the Associate Administrator for NASA's Office of Communication, Jen-Ray Wong. Jen-Ray, welcome.
Dwayne, thank you. So happy to be here.
Oh, it's an exciting day. I'm glad you're here to join the team here. And our next location you are pretty familiar with, I'm sure.
I'm very blessed, and I do know something about the great state of Nebraska. I've actually lived there for the last decade. And I have friends and family who are watching there from the path of totality. I have to tell you, this is by far the biggest thing that's happened in Nebraska as of recent. It's absolutely fabulous. I have had friends from high school and college calling me up, Facebook messaging me, asking where they can get their glasses, where they should be viewing from. So it's just a really exciting day for everyone who's watching along the path of totality. It's also a really exciting day for NASA. And in fact, this gives us an opportunity to look forward as well. And we have a future study that we are going to be doing for the to study the sun. NASA is going to launch a new spacecraft next year